Hello everyone, welcome to my new video. In today's video, we are going to solve a LeetCode problem number 11, container with most water. So let's understand the problem statement correctly. You are given an integer array height of length n. We are given an integer array of heights. There are n vertical lines drawn such that the two endpoints of the ith line. So as you can see, we have given an array of height. So each index, height at each index represents the height of this index, right? If height at 0th index is 1, so it is 1. If height at 2th index 8, so it is 8. Means height at each index represent the height of that place. Okay, so we have to find two lines that together with the x-axis form a container such that container contains with the most water. Means we have to find those two lines in which the container contains most water. As you can see in these two lines, these are the maximum possible way to find container with most water. Notice that you may not slant the container. We cannot like rotate it or something like that. Return the maximum amount of water a container can store. So we have to found, as you can see, we have to found two maximum heights in which we can store the maximum water. So there are many ways to do this, like we can do it via brute force to like checking the water with each index, like from I to everyone, and then I plus plus and to every height. But we are going to use a efficient way, like we will use two pointers, like one will be in left and one will be in right, and then we will check which one is minimum, because we have to find the minimum height, that because at the minimum height it can store water, because this is useless, right? This one is useless. We can store the water at the minimum height. That is why we have to find the minimum height at left and right. We'll increment each variable, left plus plus, right minus minus, until we found the maximum water contained by container. So let's understand why coding it. We have to create two pointers. One should be at 0th index and one should be at last of the container, like one would be here and one would be here, and we have to make a variable to max water something, in which max water in container like this to store the maximum water. Now the main thing is that we will iterate through left and right. We'll check, is this the maximum water container? If yes, then we will return it. If not, we will keep on searching. So we will use a while loop in which it will run till left is less than right. Now we have to see we have to found the minimum. First we have to found the height, because these are the indexes. L and R are the indexes. So at each index we'll found a element like height. So we'll found the left height on that index of L, because we have to found the height through the index. Similar for the right height at the index of right. Of, as we can see, if we are on this index and this index, we have to find the minimum of those two. We have to find the minimum of those two heights. So that is why we will use, first we have to create a min height between both. So we can use a math.min in which LH comma RH. By this we can find the minimum height between those two. After that we have to find the maximum water container. So max water container till now is empty, there is nothing in it. So we have to just do math.max of what? First, that value itself, do we already have that maximum water in container? Do we already have? If yes, and else we have to find the area of this and this from this height to this height. So we have to do something like a minimum height into this distance. This distance would be what? Right minus left, means right index minus left index, which would be like first min height into right index minus left. It will give us the right minus left will give us the length, I mean distance. This is the formula for founding the area. So don't get confused, it's simple. And this is the important thing. When will we have to increment left or right? See, we have to check if left of height or right of height. If left of height is smaller, like in this case, we have to increment that left variable. If left of height is bigger, so we can also have at this container maximum water. So that is why if left of height is bigger than the right of height, so we have to decrement that right of height. So if left of height is less than height of height, we have to do L plus plus. Else in the vice versa, we have to do R minus minus. And after that we just have to return max water in container. Correct, right? Let's summarize the code what we have done. So we have created two variables, left at the left pointer and the right pointer. So the left pointer would be here and right pointer would be here at the end of the index, and we have created a variable which is max water in container. After that we have used a while loop in which we are doing this loop will run till left is less than r, like something here. And after that we are storing the left height and at the left index. So yeah, it is right, means we need this height, right, and this height. So through index we are iterating through each height. So here we can have height. After that we have checking the minimum height, because we have to check minimum height and then calculate the area, because we can fill water only in on this. So that is why we are checking minimum height. After that we have to check max water container. So we will use a maximum of already stored value and this formula, because main height into this distance will give us the area. So this is how we are calculating the maximum area. After that we have to check if left height is smaller. If left height is smaller than right height, just increment left. If right height is smaller, just decrement right variable, right? After that, return the answer. Let's try to submit, run the code. L. Let's see what are the error. HEIGHT. Oh yeah, we didn't declare them, so we have to do like this. Silly mistakes. Index out of bounds. We have to do like this because length minus 1 will give us this index. Yeah, so we have successfully passed all of the cases. Let's try to submit the code. So yeah, we have successfully submitted the code. So of course the time complexity would be something like big of n, or now not like big of n, it would be like big of log n, because we are using something like binary search. So that's all for this video. Thanks for watching.